All right, lesson 4, we're covering plate motion. We're going to describe what convection currents are. We did look at these a little bit last unit, but we're going to also describe how convection currents influence plate movement. So this will make a whole lot more sense as we talk about plate tectonics. Convection currents are the movement of material caused by differences in temperature. So we talked about this last unit where heat rises. So we're going to have hotter areas of the core that are going to heat up the mantle. It's going to rise in some areas, it'll cool, and then it's going to fall back down and continue cycling. And you'll notice like we have lots of different convection currents going on here. The convection currents move the tectonic plates. So because the plates are just kind of resting on the mantle, on the asthenosphere of the mantle, our lithosphere, so the crust and upper mantle that make up the tectonic plates, are going to move based upon the movement of the convection currents. The heat from the core causes the mantle to rise and get hot. Already mentioned that. As the mantle gets closer to the top, it cools and drops back to the core. And the movement of the mantle has that circular motion. Basically covered all this. And we get our boundaries. So depending upon which way the convection current's going, that will determine whether we end up getting convergent, divergent, or transform boundaries. And we'll go into more depth with that. Okay. So continental plates may fuse together. A trench can switch direction and subduct a formerly overriding plate. New divergent boundaries may form in the center of continents. Plates may be completely subducted and disappear. The theory of plate tectonics explains how Earth's surface has changed over time and predicts future changes. So this is kind of like what I said before. There might be, like, the Appalachian Mountains are not currently sitting on a plate boundary. But we know that mountains form sometimes due to folding, which we'll get into that. But oftentimes mountains are forming due to plate tectonics. Well, if there's no plate there, then how could that have happened? Well, something must have changed where the continents could have fused together. Or something else could happen that the plate boundaries changed. Okay, so here is just our image showing Pangaea breaking up. We've got our Pangaea 250 million years ago. Then we have, you'll notice that they actually gave names to the different continents. So we have Eurasia, and Eurasia is still kind of like, if you talk about Europe and Asia, people will still refer to it as Eurasia. But then we have this Gondwana land. So they have given names to the different, like, temporary continents that they figure must have existed. Now, here's our North America. This would be our South America, Africa, Australia's in here yet, and Antarctica. And then you'll notice as we go through, like, those are gradually pulling apart and becoming the separate continents. And here's present, and then they figure in the future, we're going to get some more movement again. So here is what we're expecting in 250 million years as to what's going to happen to our continents.